Good afternoon, everyone. I'm Samik Dahal. Today, I'm going to present the presentation based on technical challenges of self-driving cars, of challenges, case studies, and ethical consideration. Um, my student ID is 2003 So, moving to the slide, introduction to self-driving cars. There are it is based on potential benefit, current state, and major challenges. So self-driving cars or autonomous vehicles are one of the most advanced application of the intelligence system. They use AI sensor of real image, uh, a real image algorithm to make driving decisions, mobility for those who cannot drive. The potential benefit are enormous. Reduce road accidents caused by the human error, um, and erase traffic in conjunction, providing mobility for those who cannot drive. Currently, most commercial like Tesla Autopilot or GMS supervising cruiser are labeled to, meaning they are required human supervised. Companies like we Waymo and Cruiser are testing level for system is restricted areas. In the restricted area, areas, but full level 5 autonomy is still a long way off. Okay, so let's move to the major challenges of the hardware system. So the major challenges of hardware systems, sensor like lidar, cameras, and radar all have limitation, and computing power demands are exactly high. Looking at the hardware like more closely, lidar provide 3D mapping, but it's expensive and struggle in bad weather. Cameras give detail images, but are less effective in low light fog. Or the radar in robust weather, but lack fine details. GPS can inaccurate in urban environment with tall buildings. So the challenging combining those these in cost effective reliable sensor like competing in another mm, issue. Car must process gigabytes of data every second, which requires specialized AI chips like Tesla FSD computers or NVIDIA platforms. Okay, moving to the software challenges. Software challenges is precious localization and mapping, decision making, and control system. In localization, centimeter level accurate is needed, and SD map are expensive to build. Um, and update. Likewise, in control system, even after decisions are made, they must be executed smoothly through accelerated barking and steering. Likewise, in perception, interpreting sensor data to recognize surrounding, classification of road sign, traffic light, pedestrian, vulnerable, and misclassification. Okay, moving to data environmental challenges. Self-driving car also face an environmental challenges. Training is based on towards certain regions, so system may perform poorly elsewhere. Stimulation helps but cannot replace real world experience, especially for rare corner cases. Weather condition like heavy replace real world experience. It experience especially for rare corner sense. I have already told, weather condition like heavy rain or snow reduce sensor accurate, and road quality and traffic pattern very wide access countries. Likewise, moving to safety and reliable challenges. Safety is a crucial concern. Self-driving can fail due to bad sensor or software glitches. They may even be hacked or tricked. Providing safe statistically is extremely difficult since billions of kilometers self-driving required. Because of this issue, regulation remain cautious about approving fully autonomous vehicle. So moving to case study of Tesla approved. Tesla take a unique approach relying visual-based system, its hardware and software. 8 camera provide 360 coverage and pure vision approach, ultrasonic sensor being removed, custom SD computer with AI chips, and over the air connectivity of software such as like software architecture, end-to-end deep learning approach, neutral network for object detection and path prediction, fit learning for customer vehicles, and frequent OTA update and for improvement. Moving to case study and Waymo approach, like we can see in the presentation in slide here, hardware approach and software approach. There are some points like regarding like leader units for high resolution 3D mapping, radar for adverse weather detection, camera for visual information and classification, high performance off-road computing, integration with detailed SD maps. So in software architecture, Tesla uses deep learning and leverage fleet learning for millions of customers worldwide. From the worldwide, updates are sent over the air, improved to the system. Okay, moving to the YME approach. Um, I finished all with I finished my presentation with YME approach. So let's move to the slide number 10. The differences between Tesla and Xiaomi strategic comparison. So here in can say in short, Tesla and Xiaomi represent two very different strategies. Tesla prioritizes scale and database deploy customer cars worldwide. Xiaomi prioritizes safety, reliable but limits deployment. Deployment to specific um, to ethics cities. This highlights the core tension in autonomy vehicles, like scalability and versus safety. So ethical issue in self-driving cars. Here ethical issue in self-driving car I see beyond technology. Self-driving cars raise in major ethical issue from responsibility, moral dilemmas, and job displacement privacy. Who is liable when accident occur, the driver, company, or the software? In major dilemmas like the trolley problem, should the car protect its passenger or predation? A job displacement, million of professional driver could lose their jobs. And privacy, car collect vast amount of data user and their moments. So let's move to the future trend of self-driving cars. In the future trend of self-driving car system will gradually to le- upgrade towards level 5 autonomy, possibly using new AI, new AI hardware like neuromorphic chips and smart cities through V2X communication will optimize traffic and safety. Also, in commercial application like autonomous trucks and delivery vehicles will likely come first. And government will play a crucial role by setting regulations and standard. Social impact will include reduced car ownership and potentially lower emission, but also job losses in driving related industries. So here I already discussed this in the previous slide. Also I'm discussing here, like in the regulated in social impact. Social impact will include reduced car ownership and potentially lower emissions, but also um, job losses in driving related industries. Moving to conclusion. In conclusion, self-driving car represent one of the most complex intelligence systems are ever deployed. They face a serious technical, ethical, and social challenges. Tesla and Waymo illustrate two very different approaches, showing a um, trade between the reliability, scalability, ethical question, and considerations. Uh, Progress will gradual rather than sudden, but if those challenges are addressed, autonomous vehicle also transfer challenges, reshape cities, and impact society on the global scale. So this is my presentation. Thank you so much for your presence. If you have any question, you can ask me. Thank you so much. So sorry, I directly moved to the last slide. Let's move.